All right, hello again. I'm Benjamin Setterholm. I am a PhD candidate at University of Michigan. Today it is my pleasure to tell you about the Michigan Young Star Imager at CHARA. So this is a new K-band instrument that we have at the CHARA array, and a nice team of people working on it here. So in brief, MYSTIC is a 4 or 6 telescope K-band combiner with the combining optics operating at 220 Kelvin. The light is fed into that system and spatial filtered by a single mode polarization maintaining fiber. MYSTIC is already running on Sky. It is automatically available with current MERC-X programs. MERC integrates with the current software architecture that we already have for MERC-X and operates with coordinated OPD tracking between the two instruments. And so the big goal at the end is when Spica will be online, then we'll have visible and then near infrared observations all happening simultaneously. So there are a few key science drivers that we had in the development of MYSTIC. As the name suggests, imaging YSOs is of primary interest. And so as we're able to do with the MERC-X instrument, the idea here is to probe the inner AU regions of Herbig, AE, and BE stars, and especially Chitauri stars will be close by. Chitauri stars will be bright in the K-band. And then together with the MERC-X and MYSTIC observations, we'll be able to get a good probe on the thermal structure with the images between the two instruments. Secondly, as Tyler Gardner had mentioned in his talk earlier today, we hope to be able to detect and characterize atmospheres of exoplanet, hot Jupiter exoplanets using precision closure phase measurements. And as you can see in this plot here, in the K-band, we expect to have better contrast between the star and planet than we do with the H-band. And here's a detection we already have of a planet in H-band with MERC. So, and then finally, we have the goal to do high spectral resolution spatially resolved spectrointerferometry. And so here's a similar plot here with gravity of a YSO and being able to see bracket gamma lines and the CO bandhead spatially resolved. So in order to accomplish these goals, MYSTIC offers 2 observing modes. The first is the imaging mode, or the classic mode, and this uses all 6 telescopes and has the same architecture as the MERC-X instrument, so giving you 20% of the light into photometric channels and 80% of the light into fringe window. And then we also offer a 4 telescope sensitivity mode, and so this is using a spare integrated optics chip from the gravity instrument, and this will be we'll start installing that next week. And so once you've chosen your observing mode, we have a slew of different prisms to choose from for the spectral resolution that you need. And that is imaged by a Saphir detector CRED1 camera with subelectron read noise. And we have a thermal background of 360 ADUs per second per pixel. So that gives us about 4 electrons read noise per coherence time. We are working on reducing that hopefully in the future. So just to give a tour of the layout, so MERC-X and MYSTIC are together on the same optical bench. So MYSTIC was installed on the lower part of this diagram here, and the light either from the array or from our internal calibration light source is coming in from the bottom left on the figure. The H and J band light passes through a set of dichroics toward the MYSTIC instrument, and K band light is reflected into MYSTIC's beam path. Following the dichroics, we have a set of shutters for lab background. Then the light passes through a set of lithium niobate plates. This is to correct for visibility losses between the S and P mode polarization modes of the light. And so by retarding the delay between these two modes, we're able to optimize visibility. The light then reflects off a series of fold mirrors that are on differential delay line controllers. And so this allows us to correct for any differences between the optical path of Mercx and MYSTIC. Then the light comes to a series of fast steering mirrors, which are used to inject the light into the fiber optics further down the beam train. And these are more efficient than the solution that we have at Mercx, but from the user's point of view, operates in the same fashion. Then we have a periscope. So the light that's going for the imaging mode passes right underneath, and the light that's going for the sensitivity mode reflects upward towards a series of off-axis parabolas. So we have 6 off-axis parabolas hanging below a mount and 4 above, which inject the light into fiber optics. And so the fibers then carry the light from the outside lab into the cryostat. So we have, for each beam, it passes through a series of 3 fibers, one for the patch on the outside, one through the vacuum feed through, and then one into the V-grooves or integrated optics chips inside the dewar. And so we spent an effort to length match these fibers as well as possible with the best solution to the imaging mode. Inside the cryostat, the light for the imaging mode follows the exact same architecture as Mercx. And so the light comes through a beam splitter, 20% off of it passes through for the photometric measurements, and then 80% of it is dispersed through a cylindrical prism, that which will form the fringes on the detector. The sensitivity mode, we have a mirror here that is on a stepper motor, which slides in and out. And so when doing sensitivity mode observations, this is a spare gravity chip. So it does the ABCD combination on 4 telescopes, providing 6 fringes. And so this is coming up in the next month. We'll be commissioning this new mode. And then finally, the light is collimated, passes through a filter wheel, and then is imaged onto the detector. So we offer a number of different spectral resolution modes. And I have a table here of typical magnitudes that you might be able to expect. Of course, for the sensitivity mode, since it hasn't been commissioned yet, these are hopefully the magnitudes we hope to achieve. To summarize, MYSTIC is a science-ready instrument. It operates in tandem with Mercx and Spica soon. It is in regular use since Mercx is the most subscribed instrument at CHARA. MYSTIC is now adding to the workhorse nature of that instrument. Since we share the same software architecture, remote observing is already ready. If you know how to use Mercx, then observing with MYSTIC is not that much extra. And it uses the same data reduction pipeline as Mercx. It was commissioned in August already. The first paper is in review using MYSTIC data, and would like to give a big thanks to the entire development team and the CHARA staff who have been wonderful in while we've been commissioning this. Thank you.
Thank you. So, questions?
Matt Anderson with CHARA Array. I'm just wondering if the faint mode for how the faint mode for Mystic will operate, since we usually run MERCX Mystic at the same time in parallel with only 4 telescopes. Is that all planned out already?
With 4 telescopes?
Yeah, with the faint mode. Is there any confusion with the system that way, or is it all just kind of, you just go with it?
Not sure.
You plan simultaneously MERCX Mystic.
Yes. Yes. So the same 4 beams that are used for the J-band, if you do J-band measurements with MERCX, are the 4 beams that we've chosen for Mystic as well. And so then you can do the beam swapping for if that's it. Yeah, that's what you mean. Got it. Yeah.
I have a question. What temperature you're planning to run the integrated optics at? That was the gravity. That was one of the restrictions that we had.
So the temperature inside the cryostat's 220 Kelvin.
Okay.
So yeah,
Quite cold. Any other questions? There was just a comment there online, but that's just repeating, I think, what you already said.
yeah. The 4 beams for gravity are selectable with the CHARA switch chart. Yeah. So
Okay, then let's thank the speaker again.